Question 7, and I think this one would have featured quite a bit earlier in the exam if it wasn't for the fact that 4, 5 and 6 were all 2-page spreads, so there wasn't really room to fit this one in earlier. Anyway, we're asked to evaluate this integral using, and the substitution is given, although most kids would have probably picked up that we just substitute the square root of the denominator here. Anyhow, off we go. So if u is x plus 2 square rooted, then when x is -1, u must be 1. And when x is 7, 7 plus 2 is 9, square root of 9 is 3. So we've changed the limits. That's probably the first mark. Then we, rather than differentiate this, let's square both sides. So u squared is x plus 2. Then we get that 2u du becomes a dx. So we've got a replacement for dx, and all we need to do then is substitute for here, which is going to be pretty straightforward because x is going to be a u squared plus 2. So here we go. We've got a 3. X becomes u squared minus 2. The square root of x plus 2 downstairs becomes a u, and the dx is a 2u du, and the limit's 1 to 3. And then when we tidy up this, we think, oh, this is pretty straightforward. The u's cancel out. We multiply the 2 in, and we've got 6u squared minus 2, which is 6u squared minus 12. So then anti-differentiate, and we end up with 2u cubed minus 12u from 1 to 3. And then a little bit of substitution. In pops the 3, 54 minus 36. In pops the 1, 2, take 12. Just watch your signs here. And then we're left with 18 plus 10 is 28. And as I say, nothing really untoward about that at all.